Hi students, this lesson is broken down into multiple videos. Some are mine and some are not mine. And it's all about discrete probability. So a discrete random variable, that means that we have a countable number of outcomes. They are not endless. These distributions are going to touch the axis and there's only so many of them. So think about one dice. The probability of us rolling a 1 is 1 out of 6. The probability of us rolling a 2 is 2 out of 6. We can't roll a 0. We can't roll a 7 or 8 or 9 or 10. Just a limited number of options. And you will notice that the pattern here is very flat. This is a uniform distribution. If we add 2 dice, the distribution changes. So we now have a bunch of different options. So we can no longer roll a 1. Over here we could, now we can't. The lowest number that we can roll is a 2. If we roll a 3, we have 2 options that meet the requirement of a 3. If we go over to 7, if we want to roll a 7, we have 1, 2, 3, 4, 5, 6 different options that meet the requirement of rolling a 7. And you notice that the distribution looks more like a normal curve that we were talking about, except this one is limited and it touches the axis. There's not an unlimited number of options. So you are going to watch this video, if you haven't already, to kind of give you an introduction to the different distributions and how this whole thing is working. There's another video on mean, really understanding the expected values. So if we go back over here and we take the mean of these guys, that's not really helpful because they're all the same. So my expected outcome might be a 3.5. Can't even do that. But over here, the expected result makes more sense. I'm expecting to get a 6, 7, or an 8, and my average would be a 7, so my expected value would fall right here. What is the most chances where most of the time is it going to fall? And then you watch another video that really starts fleshing out the idea of a probability distribution function and then this cumulative distribution function. So again, if we list out all of the outcomes and then we list out all of the probabilities associated with them all the way down, that's what this is. And this is done really well in Excel. So if we have the outcome, the chance of the outcome, and we can calculate these really quick and easy. So let's see how that works. This is posted in Canvas if you want it. So we have the possible outcomes, and if we were watching that video, this could just be listing out what are the chances of having no boys, or what's the chances of a family of 2 having 2 girls, or 2 boys, or a girl and a boy. And so what are the outcomes possible, and what were the chances of that happening? So this chance is something that we could calculate. We could list out the whole sample space and calculate it. A lot of times it will be given to us. The cumulative function starts with the first one, and then it adds what's above and the next one. And the next one is going to add whatever is above it and to the side. A hint in Excel, once we have this running sum started, we can just drag it straight down. And we should end with 1 because that should be 100%. To get our expected value, we are just going to take these 2 multiplied by each other. I am also going to copy that one down. And then right here, if I add these guys up, then my expected value for all of this is 0.6. So we are going to spend some time talking about different types of discrete distributions. There are more than this, but we are just going to focus on these 6. So it really depends on what it is used for. That's why I like this tree. So is it time-based? Yes. No. How many outcomes does it have? Is there only 2 choices, like a coin, heads and tails? Are there multiple choices? Does the probability change throughout? What is it really looking at? So the first one that we will talk about, because it is the easiest, is the uniform distribution. So in this case, it is not time-based. We have multiple outcomes. So with the dice, we had 6 outcomes. the probability is equal across all of them. So it's always equal across all. So this could be flipping a coin. So the probability of heads, 0.5, the probability of tails, 0.5. It's an equal probability. The same with rolling a dice. 6 options, equal chance of me getting 6 each time. Or anything else that's equal. So the distribution looks very flat. There's no arch, it's very flat. The probability is 1 divided by the number of values. So if we're talking about the coin, it's 1 over 2. Talking about the dice, it's 1 over 6. We can calculate the expected value by taking the max value divided by the plus the min value divided by 2. But again, like we talked about at the beginning of this, that's not really that interesting. So this is uniform distributions, and we will move on to the next one in the next video.